When you are stuck and clueless, remember that there is always an idea to overcome it. Follow that idea and try and practice as much as you can so that you can improve gradually and you feel victorious at every single day. And that is the beauty of learning. So listen to this carefully so that there will be certainly an element of achievement at the end of this video. And today's topic is mathematical induction, and this is related to MFCS DMS and DMGT and also for intermediate 1A. So here in today's video, so using mathematical induction, we have to prove the following, that is 2 into 3 plus 3 into 4 plus 4 into 5 and so on up to n terms, which is equal to n into n square plus 6n plus 11 by 3 for every natural number. See here, in order to find this, we have to use the mathematical induction. First of all, we have to find this nth term. So what will be this nth term and how to find this nth term? See, in order to find the nth term, see, according to our problem, so the first terms here is 2, 3, 4. First, see here, first of all, we have to take 2, 3, 4, which are in AP, because the common difference between any two numbers is 1. Same. So, as you have a formula that Tn is equal to A plus n minus 1 into D. So, here what is A? The first value is A. So, here A value is equal to 2 and the common difference D is equal to 3 minus 2, which is equal to 1. So, after substituting A as 2 and D as 1 in this formula, so we got Tn as n plus 1. This is the nth term for the first series. And the next one is 3, 4, 5 and so on. So here if you observe this 3, 4, 5 are again in AP. So we have a formula that Tn is equal to A plus n minus 1 into D. Here if you observe this one, the first value here is 3. So A value is equal to 3 here and the common difference 4 minus 3, which is equal to, the D value is equal to 1. So if I substitute A is equal to 3 and D is equal to 1, so this is 3 plus n minus 1 into 1. So this is 3 plus n minus 1. This is n plus 3 minus 1 is equal to 2. Here these first term and second term are multiplied and therefore the nth term will be the multiplication of this, that is n plus 1 into n plus 2. Clear? Therefore now our question so will be, see here, this is 2 into 3, 3 into 4 and so on. So this will be our nth term. Just now we found, that is n plus 1 into n plus 2 is equal to n into n square plus 6n plus 11 by 3. So we have substituted this nth term and this will be the question, and therefore we have to take that as the statement. Let Sn be the given statement. So this will be the statement, and after writing the nth term here as n plus 1 into n plus 2, and this is the total statement. First of all, we have to keep, according to the mathematical induction, we have to substitute n value as 1. The first step we have to take. So we have to check LHS as well as RHS. So coming to this LHS. So if I take LHS here, this is 2 into 3, which is equal to 6. And coming to RHS part, so this is n into n square plus 6n plus 11 by 3. In this, if I keep n is equal to 1 here, so in place of n as 1, so this will be 1 plus 6 plus 11 by 3, which is equal to 18 by 3. The answer is equal to 6. So here if you see, LHS value is equal to RHS value, and therefore we say that, so the statement is true for n is equal to 1. Clear? And next one, the second step which we have to take is assume that S of k is equal to 0, which means that we have to take n is equal to k as a true statement. So in this, according to our statement, so we have to put n is equal to k. So after keeping n is equal to k, so this will be k plus 1 into k plus 2, which is equal to k times of k square plus 6k plus 11 by 3, and take it as equation number 1. So we have assumed S of k is true. So this will be the first equation. And see here, so after taking n is equal to k, this is our first equation. And step 3 here is we have to prove that S of k plus 1 is true. So for that we have to keep n is equal to k plus 1 and we have to verify LHS part is equal to RHS part. So here what is the nth term here? Nth term is nothing but n plus 1 into n plus 2. Just we have found here what is our nth term here? The nth term is nothing but n plus 1 into n plus 2. We have substituted here and see here nth term is n plus 1 into n plus 2, and in this if I keep n is equal to k plus 1, so this will be in place of n as k plus 1, this will be k plus 1, in place of n as k plus 1, this will be k plus 2, and total this will be k plus 2 into k plus 3. Now in order to solve, I am going to add this k plus 1th term on both sides of equation 1. So what is our equation 1? So equation 1 is this one after keeping n is equal to k. So here in this side and that side, both sides I am going to add this k plus 2 into k plus 3. Clear? So this is our equation 1. So this is our equation 1. In this equation, I have added this k plus 2. See here, this is this k plus 2 into k plus 3 on both sides. Now I am going to solve this. So I am going to take this RHS and solve what happens here. So here, if I take here 3 as LCM, and see this will be k times of, this is k square plus a 6k plus 11. So this will be 3 times of, this will be k plus 2 into this value is k plus 3. Clear? Now if I multiply with k inside, so this will be k cube plus this value is 6k square, this value is 11k, and this is going to become 3 times of, if I multiply, so if I multiply, this will be k square plus 3k. So again if I multiply with 2, this will be 2k plus 6 by 3. Clear? And now this is going to become k cube plus 6k square plus 11k, and this is 3 times of, this is k square. So these two are of like terms. This is 3k plus 2k, which is equal to 5k plus 6 by 3. And my next step will be, see here, this will be k cube plus 6k square plus 11k. If I multiply with 3, this will be 3k square plus 15k plus 18 by, this value is 3. And now see here, so the first thing here is this is k cube plus, so if you see, this is a 6k square and this is 3k square. Total this will be 9k square. So this is going to become 9k square plus, and next one k terms. So this is 11k and this value is 15k, and total 26. So this is going to become 26k plus, see here the constant term here is 18 by 3. And clear? Now we have to show it is true for n is equal to k plus 1. For this there is a logic here. So for that I am going to take this step. See here, this is the logic which I am going to asking you to remember. See here, this is the question. In this we have to keep n is equal to k plus 1. Clear? So this is the LHS part. If I keep k plus 1 here, this will be k plus 1. So this is k plus 1 whole square. So in place of n, if I keep this one is k plus 1, and next one this is 11 by 3. Clear? And now this one will be k plus 1. So this is k plus 1. So if I expand this one, this is a square plus b square plus 2ab. This will be 6k plus 6 plus 11. Clear? And the next thing here is by 3. And the next one here is, this will be k plus 1. So this is k square. So if you see, this value is 8k plus 1 plus 6 is 17. 7. So this is 18 by 3. See here, keep it as a secret. And next one we need here k square 8k plus 18. So here also we have this one. So I am trying to write this as, I need 8 here. So I am splitting this as 8k square plus k square, as I need 8k here. So I need again 18. And next one, so this value is again k terms here. And the next thing which I am going to do is 18k plus 8. And next one, this 26 can be written as 18k plus 8k plus 18 by 3. See here, for my convenience I am writing this one as, so 9k is written as 8k plus k square, and next one this 26 26k, I wrote this as 18k plus 8k. Clear? And now I'm writing in an order as this value will become, this is 8k cube plus 8k square plus this one is 18k. Together, I'm writing these three together. And next one, this value will be k square plus this value will be 8k plus 18 by 3. You'll see why here. So if I take k common from this will be k square plus 8k plus 18, and here also this will be k square plus 8k plus 18 by 3. So if you observe, these two terms are like terms. So I'm taking this as common. So if I take this common, so what happens here? So if I take this common, this will be k plus 1 times of, this is k square plus 8k plus 18 by 3. Clear? Now see, so just now we wrote till here, that is k plus 1 into k square plus 18k plus 18 by 3. So you take the back step here. So here k square is as it is, and 8k is split into 2k plus 6k, and this 18 is split into 1 plus 6 plus 11. So do the same as here. So taking the back step, this is k plus 1, this is k square, this 8k is split into 2k plus 6k, and this 18 is split into, see here, this 18 is split into 1 plus 6 plus 11. So 18 can be written as 1 plus 6 plus 11 by 3. And now writing in a proper order, so this will be, see here, this will be a square plus 2ab plus b square. At one time I am writing, that is k square plus 2k plus 1, and these two here, that is a 6k, this is a 6k plus a 6, 6k plus a 6. So this will be 6k plus a 6, and next one here, this will be, what is left over here? This is 11 divided by 3. And see here, this will be k plus 1 times of. So this can be written as k plus 1 whole square. If I take 6 common, this will be k plus 1. So if I take 6 common from these two, if I take 6 common from these two, this will be 6 times, and this value is plus 11 by 3. And therefore this can be written as k plus 1 times of, this is k plus 1 whole square plus 6 times of k plus 1 plus 11 by 3. Now this is nothing but s of k plus 1. I'll show you how. So what is our nth term here? So our RHS value is nothing but n into n square plus 6n plus 11 by 3. So in this, if I keep n is equal to k plus 1, so this, if I keep n is equal to k plus 1, I'll show you, this is k plus 1, and see here, this is n square. So in place of n, if I write k plus 1, this will be k plus 1 square, and this value is a 6n. So this is 6 times of k plus 1 plus 11 by 3. So this is true for n is equal to k plus 1. Therefore, s of k plus 1 is true. Therefore, s of k plus 1 is true. So we got the LHS part. Therefore, the question here is true for every positive integer, that is 2.3, 3.4, plus and so on. The nth term here we found is n plus 1 into n plus 2, which is equal to n times of, this is n square plus 6n plus 11 by 3. So this is how we have to do. And back to the beginning, first of all, it is given like this. The question is given like this. First of all, we have to take the nth term. So these two are in the arithmetic progression. The first nth term is n plus 1 and the next one is n plus 2. After multiplying, this will be the statement. And see here, after considering this as a statement, we have to keep n is equal to 1. So this is the LHS part, that is 2 into 3, which is equal to 6. And this RHS part, if you keep n is equal to 1, so we got the same answer as 6. Therefore, LHS is equal to RHS. Therefore, it is true for n is equal to 1. And therefore, we have to assume S of k is true. So we have to assume that n is equal to k is true. So this will be the first statement here. After taking this as a first statement, we have to prove the next step as n is equal to k plus 1. So here the nth term is this one, that is n plus 1 into n plus 2. And if you keep n is equal to k plus 1, so this will be k plus 2 into k plus 3. And therefore in the first equation, so I am adding k plus 2 into k plus 3 on both sides. And after taking the RHS part here and just I've did all the calculation here, if you go through this video, so here I've taken the small step as this one. So here this is the nth term, so this is the RHS part. In this, if I keep n plus 1, so make it as a rough work here. If you keep k plus 1 here, so these are the steps here. So I got k square plus 8k plus 18. So the 9 is split into 8 plus 1 and 26 can be split into 18k plus 18. So I have 18 here, therefore I have split this 26 as 18k plus 18 here, and therefore so these three terms are taken together, that is k cube, 8k square and 18k together, and k square plus 8k plus 18 together. So if you observe, if I take k common from this, so this is k square plus 8k plus 18, and this is also k square plus 8k plus 18, and after taking these two as common, so we got k plus 1, and therefore see here this 8k can be written as, so this 8k can be written as 2k plus 6k, and this 18 can be written as 1 plus 6 plus 11. So take a back step and write this as 8k as 2k plus 6k and 18 as 1 plus 6 plus 11, and you write this k square plus 2k plus 1 as one term and take 6 common from these terms, and therefore definitely so this is the value when we keep n is equal to k plus 1. So this is our RHS part, and therefore it is true for n is equal to k plus 1, and therefore the whole statement is true. And this is how we have to solve. Take this simple step and idea, go to the back steps and adjust, and therefore you can solve. Thank you so much for watching and staying till the end.